Hey guys, it's Mrs. Rooker. Go ahead and do the review problems. So pause the video, do the review problems, and then I'll have the solutions up there for you when you unpause. All right, here are your solutions. For number one, I just did a sketch of the graph. I found the vertical asymptote by setting the denominator equal to 0. And then I found the horizontal asymptote by looking at the degree of the top over degree of the bottom. The degrees were the same, so I did p over q, negative 5 over 2. And then the end behavior is just where is the left end approaching. The left end is approaching the horizontal asymptote, which is negative 5 halves. And then where's the right end approaching? Also approaching the horizontal asymptote, which is negative 5 halves. So both ends are approaching negative 5 over 2. Then to find the graphing form, we use synthetic division. I did the opposite of negative 6 on the outside, and then 4 and negative 14 on the inside. When I did synthetic division, my remainder was 10. And remember, the remainder always goes over whatever you had divided by. So we had divided by x minus 6. And then I just moved the 4 to the other end. And that's how I ended up getting 10 over x minus 6, and then plus 4 on the end. All right, go ahead and pause the video if you want to write all that down, if you didn't have it already. And then we are going to move on to graphing in different forms. Ooh. Sorry, I was freaking out. All right, graph each rational function, state the wholes, vertical asymptotes, horizontal asymptotes, x-intercepts, end behavior, domain, and range. So lots of stuff. And then the first thing is, if possible, it's not always possible, but if possible, we're going to write this in graphing form if it isn't already. To get it into graphing form, I use synthetic division. So I'm going to put 2 and 1 on the inside, and then positive 4 goes on the outside. It's the opposite of that. Bring the 2 down. 2 times 4 is 8. Add straight down, I get 9. And then that always goes over the thing that we had divided by, because that's our remainder. The thing that we had divided by was x minus 4. And then to write this in graphing form, just do f of x equals, we put the 9 over x minus 4 first. And then we move this 2 to the other end, so plus 2 on the end. And that's now in HK form, or graphing form, where this is your H and that is your K. And that will give us the vertical and horizontal asymptotes. So the vertical asymptote is x equals 4, because we do opposite of H. And then horizontal asymptote is 2, y equals 2. I should also check for wholes. Wholes can be found by reducing factors. Nothing factors on the top, nothing factors out on the bottom, meaning no factors are going to reduce, so there are no wholes. I'm going to now sketch this, and then I'll answer the rest of the question. So we have a vertical asymptote at 4, 1, 2, 3, 4. And a horizontal asymptote at 2. In graphing form, I've got a positive 9, so that means everything's going to go in the first and third quadrants. I can also find the x-intercept. That would be a good way to know exactly what my curve kind of looks like. Remember, to find the x-intercept, we set the top equal to 0 when it's in standard form. So if we set this equal to 0, subtract 1, divide by 2, we get the x-intercept is x equals negative 1/2. So it crosses the x-axis at negative 1/2. And then we'll just kind of sketch our curve. It's not going to be perfect, but it's going to look something like that. It should be the same on both sides. All right. last couple questions, it asks for domain, range, and end behavior. So domain, how far left does it go? How far right does it go? So it goes forever left and forever right, but there is a vertical asymptote, and it's never going to touch that asymptote. So the domain is all real numbers except x cannot equal 4, which is where the vertical asymptote is. Actually, I'm going to write all real numbers except x cannot be 4. You could also write this in interval notation. That would be -infinity to 4, but not including 4. And then 4 to infinity, but again, parentheses because we're not including 4. All right, range, it can go forever up and forever down, but there is a horizontal asymptote, so it can't touch the horizontal asymptote, so it's going to be all real numbers except y cannot equal 2. You could also write this as -infinity to 2, and then 2 to infinity, but not including 2. And the very last thing, end behavior. So take a look at this left end. The left end is going to be as x approaches -infinity, the function is approaching that horizontal asymptote, which is 2. And then same idea with the right end. This right end is x approaches +infinity. The function is also approaching that horizontal asymptote again, also approaching 2. All right, so that is it for that problem. Go ahead and pause if you need to catch up on it. Move on to number 2. So number 2 is already in graphing form. So I'll just say that that's been done for us. That was already in graphing form. I'm going to look for holes first. I would factor and see if factors can reduce, but nothing can factor out here or here. Nothing reduces, meaning there are no holes. Since it's in graphing form, to find the vertical asymptote, I do my h. So h is going to be opposite of this. X equals -2. And then horizontal asymptote is k, so that's going to be y equals 1. So vertical asymptote at -2. Horizontal asymptote at 1. And now we'll move on to find the x-intercept, so we know kind of how the curves are going to look or where they're going to be. Normally, if this was in standard form, I would just set the top equal to 0, and that would give me my x-intercept. But this isn't in standard form, so I instead will have to find the 0 of the function, because that's also an x-intercept. So I'm going to set the function equal to 0 and solve for x. So I'll subtract 1 from both sides. We get -1 equals -1 over x plus 2. I want to get rid of this x plus 2 on the bottom. So I multiply both sides by x plus 2. Distribute the -1. I end up with -x minus 2 equals, and then those will cancel. We'll get -1. Add 2 to both sides. We get -x equals 1. So x must equal -1. So that's my intercept. X equals -1, or we could write this as -1 comma 0. I'll plot that. That's my x-intercept, which means my curves must look something like this. Remember when you draw these to be careful about not crossing the asymptotes. All right, I'm going to erase some of this work, so if you didn't get it down, maybe pause the video so you can write it all. Alright. Domain is going to be everything except x cannot equal the vertical asymptote, which is at -2. And then the range is everything except y cannot equal the horizontal asymptote, which is 1. And end behavior, the left end, so we're going to write that as x approaches negative infinity. The left end is approaching that horizontal asymptote, which is 1. And then the right end is also approaching the horizontal asymptote, which is 1. So the right end is as x approaches positive infinity. The function is approaching 1. It's always going to be that horizontal asymptote that everything is approaching. All right, so pause the video if you need to write all this down. All right, next one, getting into some fun stuff. So the first thing says graphing form. Something like this is going to be, well, very difficult to get into graphing form. Actually, it doesn't really have a graphing form the way we do graphing form, so we're not going to do that part. We're just going to skip ahead and focus on holes. So to find holes, we factor out the top, factor out the bottom, and see if anything cancels. Well, top doesn't factor, but the bottom does factor. So I'll write this as x minus 1 over, factor the bottom, we see what multiplies to 3, but adds to negative 4. It's an easy trinomial, so I can just go straight from the big X to the parentheses. What multiplies to 3 but adds to 4, or negative 4, well, it's got to be 3 and 1, except they're both going to be negative in order to multiply to a positive, but add to negative 4. So this is going to look like x minus 3 and x minus 1. Hopefully you notice that we've got a hole. So the hole is going to be located at x minus 1 equals 0. We set it equal to 0 when we have a hole. So the hole is located at x equals 1. We're going to deal with that later after we graph it. We'll put the hole there after we're done. Then, since this reduced, we're left with 1 over x minus 3. So we could kind of consider that our graphing form. But just remember that there will be holes. This actual function wouldn't have holes, but the original function did. Vertical asymptote, set the bottom equal to 0, so it's just going to be x equals 3. We don't need to count that hole. And then horizontal asymptote is going to be, the number on the end. Well, there's no number on the end, so it's just going to be 0. Or if we were looking at the original, we'd find the horizontal asymptote by doing degree of the top over, the degree of the top over degree of the bottom is degree of the top is less than the degree of the bottom. So that was case 2, which actually no, sorry, that was case 1, and the horizontal asymptote is 0 for case 1. All right, now let's graph. Vertical asymptote at 3. Horizontal asymptote at 0. It's not going to have an x-intercept because there's an asymptote at on the x-axis, meaning it's never going to touch there. So there's no x-intercept. And I know that because it's positive here when it's in graphing form, my curve is going to be in quadrant 1 and quadrant 3. Now this was just a really rough sketch of it. I don't know if it's exactly going to look like that. So what I might do is plug in to find at least one point so I have an idea of where that curve's going to be. Again, let's say, I don't know exactly where these curves are going to be, but I want to find maybe the point 2 comma something. I want to see where 2 is located so I know exactly where on this line to draw that curve. So I'm going to plug in, I'm just going to do to the new function, not the one with the holes. Y equals 1 over 2 minus 3. So y equals 1 over negative 1, which is going to be y equals negative 1. So that means that our function contains the point 2, comma, negative 1. That will just give me an idea of where the curve is. So it's going to be fairly close. And then I'm supposed to have a hole located at 1. So I'm going to go to where x is 1, either straight up or straight down to meet the curve, and put a hole there. So that's the hole. It's just going to be an open circle. And then I'm just going to resketch this graph a little bit so that it's nice and close, just like my other curve again. All right. Erase to make some room. Domain is all real numbers except x cannot equal a couple things. X cannot equal 1 because that's where the hole was. X can also not equal 2 because that's where the asymptote is. Nope, not 2. 3 is where the vertical asymptote is. All right, and then for range, it's y cannot equal whatever the horizontal asymptote is, so that's 0. End behavior, both ends are going to be approaching the horizontal asymptote. So f of x is approaching 0, f of x is approaching 0. I should always write, this is the left end, and this is the right end. All right, I gotta start moving faster since this video is already long. All right, why don't I have you guys try that? No, that's a little tricky, so we'll do this one together. So finding the holes, factor and cancel out holes. So when I factor this, this factors to x plus 2 times x minus 2, because that was a difference of perfect squares. And then this, what multiplies to 4 but adds to negative 4. Well, that's negative 2 and negative 2. So there is going to be a hole at set x minus 2 equal to 0. So it's going to be at x equals 2 is where the hole is located. To find the vertical asymptote, set the bottom equal to 0. So if I set x minus 2 equals 0, I get that the vertical asymptote is going to be at x equals 2. Well, this is kind of a weird situation because there's a hole and a vertical asymptote there. If there's a hole and a vertical asymptote, we're going to count it as the vertical asymptote if there were multiple parts here. If it was just the one, then it would just be a hole. All right, horizontal asymptote. To find the horizontal asymptote, we do the cases. Degree of the top is the same as the degree of the bottom, so we do p over q. P is 1, q is 1, so it's just going to be 1 over 1, which is 1. So vertical asymptote at 2, horizontal asymptote at 1, all right, and then find the x-intercept. I find the x-intercept by setting the top equal to 0. So that's going to be x plus 2 equals 0. So x equals negative 2 is going to be my x-intercept. X-intercept is negative 2, so my curve's going to look like this. And then my other curve will just kind of mirror that. It's not perfect, but it's okay. All right, domain. X, well, oops, I'll put all real numbers, except x cannot equal 2, because that's where the asymptote is. That's also where a hole would have been if the asymptote didn't take over. All right. Range is all real numbers except y cannot equal 1. And then end behavior, as x approaches negative infinity, the function approaches 1. And as x approaches infinity, the function also approaches 1. That's where the horizontal asymptote is. All right, really quick, we are just going to take this first function in graphing form and shift it up 4, left 5. So up 4 means I'm going to add 4 to the very end because that's our k. And then left 5, we always do opposite of this. So instead of minus 5, I'm going to do plus 5 to the k value. So this is going to end up being 1 over x plus 8. And then negative 9 plus 4 is going to be negative 5. And then the very last one, I would first move this into graphing form, and then I can do the shifts. 2, 1, negative 5 goes in the front, bring the 2 down, multiply, we get negative 10, add straight down, we get negative 9. Remember that will always go over the divisor, so x plus 5, and then I move this 2 to the end. So that is this function, but in graphing form, but then I'm going to shift it down 5. Oops, not down 5, down 2. Down 2, and then right 6. So that's going to be minus 6 for the k value. So 5 minus 6 is going to be negative 1. And then these 2's on the end will cancel. So there's no number on the end. That's our answer. All right, that is it. Sorry this video was a little bit long. I'll try to make the next one shorter. Ooh, it's glitching out of me. All right, have a good one, guys.